Number 33 is worth doing. Let's try number 33. Number 33. So y is equal to 2x, and 4x minus 2y is equal to 0. Nice. What was the first thing you needed to do if you were going to solve this by substitution? What was the first thing you were going to need to do if you were going to solve this by substitution? Yes. Well, this one set it up nicely, but let's say this was some general system of equation. What was the first thing you would need to do? Isolate. So you need to isolate, exactly. What's nice about this one is that it's already isolated. What do we have? We have y is equal to? So we plug that in, 4y. So you get 4x minus 2 times 2x equals 0, which is 4x minus 4x equals 0, which is 0 equals 0. If you end up with 0 equals 0, what does that mean? It means it's always true. It means it's always true. Any value that works in one will work in the other. So if you find a solution to the first one, it will be a solution to the second one. It means it's the same line. It means it's the same. So where does a line intersect with itself? So number of solutions, infinite. What are the solutions? Y equals 2x. Anything that I'm not going to ask you that, but I could down the road. If I ask you what are the solutions, anything on the line. Anything on the line. What's the domain of this function right here? What's the domain of that? Yeah, what's that called? What's that called? Yes. No, that range. The domain, yes, negative infinity, comma infinity. Yes, but what's another way to say that? We said it many different ways. All real numbers, ARN, or what? Remember that big R with the two? All real numbers. So that one right there, the number of solutions is infinite because it's the same line. Where does a line intersect itself? All the places the line exists. Any others from the homework that you want to talk about? Alyssa. Number 31. 1/2 x plus 1/3 y is equal to 3, and negative 3x plus y is equal to 0. Nice. So we're supposed to do this by substitution. Okay. Anybody want to give a pro tip as to what you could do to make this a little bit easier to deal with? Yeah, Katie, what could you do?
I would add for the second.
Yep.
One, I would add 3x.
Yeah, so y equals?
3x.
And then what do you do with y equals 3x, Katie?
Plug it in.
So we isolated, and then we are now substituting. Right there. 1/2 x plus 1/3 times 3x is equal to 3. Okay, how many equations is that? That's one equation. And how many variables are in there? 1. Is that a good thing? Yeah. Yeah, it is. It's very good. So we have 1/2 x plus what? Just x, right? If you have half of an x and an x, how many x's is that? Yeah, so 3 over 2, x is equal to 3. What do you multiply both sides by to get rid of the 3 over 2? Multiply by 2, you end up with 3x equals, so x is equal to? Once you get x is equal to 2, we need to solve for, oh, we know that. We know x is equal to 2, so y is equal to 3 times 2 is 6. You then, at the end, would write the answer being 2 comma, oh, is it 2 comma? There, I just didn't write that correctly. Thank you. 2 comma 6. Now, theoretically, what should you do at the end? What's a great thing to do? Check. Check, check, check. Okay, any last? So it tells you to use substitution. What do you want to solve for? Okay, what's y? Y is equal to what? Yeah, this is pretty much the same as the other one. We plug it in there. I'm not going to finish this one. You plug that in. Did we answer your question already? Well, I guess we'll finish it if you want to.
My problem was like this one sucks.
Oh, okay. So did we saw, hey, I fixed it. Yay, wonderful. First thing I always check when a kid calls me over and says I need help on a question from the book, the first thing I always check is, did they copy it down right?
Yeah, that's the other problem.
The best kind of question I get, or the best mistake, I love it is when kids write the first half of one problem and then the second half of the other, because it usually makes it much, much harder or impossible. Katie, you have another one. 35. What's your question on 35, Katie?
So like you're supposed to use the same strategy
you're supposed to use substitution, yep. And they have x is equal to 5y, so where do you plug that in?
Okay.
Right there. So 5 times 5y is minus 25y is equal to 5. So this is 25y minus 25y is equal to 5. This is 0 equals 5. Is that true? Not true. So how many solutions are there? No solutions.
Okay. I think I need it way more complicated.
Okay. There's no solutions of this. There's no solutions. Why? Why would a system have no solutions? What's the one case where it has no solutions? They're parallel. These are parallel lines. Parallel lines. They're both parallel. What's the slope of the first one? What's the slope of this one? Nope. Close. 1 what? 1 over 5. If you were to put this in the slope-intercept right here, you'd end up with, 5x minus 5 is equal to 25y. So y is equal to 5 over 25x minus 5 over 25. What's 5 over 25? 1/5 x minus 1/5. So these lines, they are parallel. The slope here is y is equal to slope 1/5 x. So do they intersect? No. Put everything away except a pencil. You're not going to do this. You're not going to touch anything. You're not going to write anything down. You're going to do exactly what I asked, which is just sit there and do nothing except watch. Rachel? If you are in the main screen of your calculator and you go hit y equals, which is in the upper left, you end up with this screen right here. y1, y2. Each of those is a separate place to write a different function. Separate place to write a different function. Okay. What do you notice though? It's y1, y2. Each one is a separate function. It's y in terms of x. It's y in terms of x. Our equations that we started with, are these y in terms of x? No, these are in what form? These are in standard form. The calculator wants them to be written in anything. Slope-intercept would be the closest thing we would come. It could be anything on the other side, but it has to be y on one side and everything else on the. So let's do that. Y is equal to negative 7y is equal to negative 8x plus 3. What do I divide everything by now? Divide by negative 7. What do I end up with? I end up with y is equal to 8 over 7x minus 3 over 7. Are you okay with that right there? Are you okay with that? Okay. So y is equal to, parentheses are important here. Is it 8 divided by 7? Was that it? Minus 3 divided by 7. All I've done is I've typed that into my calculator. In the upper right, you see the graph. The graph button is going to go red for a second there. Oh, there's our line. Nice. Yeah. Now what do we need to graph? We need to graph the other line. You can put both in. I just wanted to show you that it looked like that. So if we go back to our work here, what do we need to put it in first? Slope-intercept. So negative 4y is equal to negative 9x plus 6. So y is equal to 9 over 4x minus 6 over 4. So if you guys could remember that, that would be helpful. So we end up with y is equal to, and are the parentheses important? Yeah. 9 divided by 4x, right? What was the y-intercept? Minus 6/4. Can I simplify that? 3 divided by 2, right? Look, if I graph this, let's see what happens. Is there a second? Oh, there's a second line. How many times do they intersect? Once. So could you theoretically zoom in and look at the graph and make an estimate? But there's also if you hit second trace, which is calc, look what options you get. Which option do you think I'm going to select? Intersect. So you can hit 5 or go down and hit enter, but hit 5. What's it asking me for? First curve. You see where it says first curve right there? If I move my cursor left and right, what do you notice? You see that cursor that's on the line right there? So when you're on the line you want, you hit enter. Why is it asking you to select the curve? Could you have more than 2? Yeah, it's asking which 2 do you want to find the intersection of? Okay, I hit enter twice. And now it's asking me for a guess. If these weren't lines, if they were curved, could they intersect more than once?
Yeah.
So you're telling it where do you want the calculator to look? So I hit enter. Look what it does. What does it give me right there? So this is cool because it just gave us the intersection. Are those nice decimals?
No.
No, you wouldn't consider them to be nice decimals. You would really like to know if you did your work correctly though, right? You did your work. You didn't get decimals. What did you get? You got fractions, which would make sense because you're not machines. Writing that as a decimal is kind of hard, right? A little bit. You have to do the division. It'd be not cool. So how do you check that? Well, there's a really cool aspect on your calculator. What you can do, everybody take a look. Don't play around with anything. After it does a calculation like that, notice how it said x equals a number and y equals a number. If you just type x on your calculator and press enter, look what it saved. It saved that decimal. If you type y, which is alpha and y is now alpha 1, and hit enter, it saved both of those values. There's a really cool feature on your calculator called 2-fraction. It's under math. If I go x here and then math, look at the top value, 2-fraction, and I hit enter, look what it gives me. Oh, sweet snap, you were right. Okay, vindication. What do we want to check? Let's check x, or let's check y. Alpha 1, 2-fraction. What do we hope it is? What do we hope it is?
21 over 31.
What do we think? 21 over 31. Booyah! There we go. Nice. So keep in mind, your calculator can find intersections, and also, if it has a fraction, it will convert it to the lowest fraction for you, the most reduced fraction. It's kind of cool. So once again, what form do the lines have to be in? To enter slope-intercept form. You have to isolate y. So slope-intercept is the one you're aiming for. You'll notice when you hit graph, you can pops up there. There's some window issues we'll deal with later. But the cool thing is, under calc, what do you see under calc? Intersect. Intersect. These are all the other ones are things you'll use in calculus, but intersect is great because intersect will work on any function you have graphed. You have to choose the first function, the second function, and the guess. And guess what it gives you? Ooh, it gives you the intersection. Is that helpful? Yeah. So if you have your calculator,